In this question, it is given that a black body at 1227 degrees Celsius emit radiations with a maximum intensity at a wavelength of 5000 Angstrom. So you can write the temperature. Initial case, the temperature is given as 1 to 1227. It is given in degrees Celsius, so we can add 273 to convert it into Kelvin scale. So we can write that is equal to 1500 Kelvin is the value of initial temperature T1, and the corresponding wavelength is given as lambda 1. We can take it as that is equal to 5000 Angstrom. The temperature of body is increased by 1000 degrees Celsius. That means now the temperature, initial temperature was 1500 Kelvin. Now it is increased by 1000, so the value will be 1500 plus 1000, because change in temperature in Kelvin scale and degree Celsius scale are same. So in both the temperature scale it is going to increase by 1000, so we can write that is equal to 2500 is the final temperature. The maximum intensity will be observed at Rm is to find out what about the value of wavelength lambda 2 for it. So we can write from the equation lambda is inversely proportional to T. We can write lambda 2 divided by lambda 1 is equal to nothing but T1 divided by T2. So we can write the value of lambda 2 is equal to lambda 1 into T1 divided by T2. Now we can just substitute the value. Lambda 1 in the first situation is nothing but 5000, and T1 in the first situation is nothing but 1500, and T2 in the second situation is nothing but 2500. So we can write this will be, we can cancel this 100 and 100, and you can write if we are dividing by 5, so this will be 3 and by 5, and this 5 and this 5 get cancelled, so we can write this is equal to 1000 into 3 will get the answer as nothing but 3000. So now the wavelength is going to be 3000 Angstrom.